Okay, now as depicted in this figure, our line is attached to the distilling column at nozzle N1 and to the reboiler at nozzle C. The line begins relative to the flow direction at nozzle N1 with a flange and an elbow welded together. In order to draw our isometric, we will consider nozzle N1 as our starting point. This nozzle is perpendicular to the north direction and is pointing west as depicted here. So we can draw it on the isometric as follows. Next, we will draw the connecting flange. Then notice here that the elbow is oriented toward the north according to the north arrow. Therefore, if the line turns north on the arrangement drawing, it must also turn north on the ISO, as seen here. Now, to determine the distance a pipe travels in the north direction or any other horizontal plane, you must use two coordinates. Remember, horizontal dimensions are calculated using coordinates, and vertical dimensions are calculated using elevations. So, if there were a need to determine the distance a pipe travels in a vertical plane, you would need one of the following: elevation callouts, which are found on the plan view drawing, or an elevation drawing that graphically depicts the amount of vertical change. We will see this in detail further ahead. Also recall, elevation changes can be shown on the piping arrangement drawing in the form of callouts, but the elevation callouts must be adequate enough to determine the length of the pipe traveling in the vertical plane. After the north run, an elbow turns west, and the line travels below the reboiler. Note how the elbow is also shown turning west on the ISO. When the pipe aligns with the center line of the reboiler, another elbow turns the line up and into nozzle C. Now, isometric drawing symbols for 90-degree and 45-degree elbows are typically shown with square corners, as opposed to the round corners found on arrangement drawings. However, it is not unusual for some companies to draw elbow symbols with round corners. Note also that the equipment nozzles, as highlighted here, are drawn double line on ISOs. This is done to distinguish them from flanges and valves. Other important details about our line that must be represented on the ISO are shown in the next figure. They include intersecting coordinates for the center of the equipment, as highlighted here in blue, nozzle elevation, as highlighted here in green, nozzle number, and the name or the number of the piece of mechanical equipment. Finally, keep in mind that if a nozzle on one end of the configuration happens to be of a different size or pound rating than the rest of the pipe, then its mating flange is considered to be out of spec, and that information must also be shown on the isometric near that particular nozzle.